Hello and welcome to the Global Star Party, your weekly look at the world of space and astronomy with live views of whatever we can find out there if the clouds aren't in the way. You are watching our weekly show. This time round, it's the Australian Eastern Hemisphere nighttime edition, or like what we like to call the Paul Stewart special now, because let's be honest, he saves us every week. Joining me today is my co-host Dylan, or Dylan, the International Space Station in front of the Moon Man.
Hey, how's it going, everyone? Broadcasting from Surfer's Paradise tonight from a small hotel room here. I did have my telescope ready to go, but there has been an Antarctic weather event that's pushed up a lot of cold air across most of Australia, so most of our Australian astronomers are out of action today. But yeah, looking forward to seeing what Paul's got to show for us, and we've got some stuff from the Flickr page as well, and a couple of other things I'd like to share out too.
And of course we have Russell, who is coming from us from I presume, a rather cold location, hopefully bringing some live stuff. Hello, Russell.
Hey, Chris.
So where are we coming from, and what do we have for us today?
Coming from Nova Scotia, and I have some live sun if I can ever get it into focus.
Well, at least it's easy enough to find. It's the big bright thing, although having said that, though, the sun can be remarkably hard to find. Well, welcome, Russell, and also welcome, Paul, who is currently a twitching black thing, which I'm curious to find out about. But hello, Paul.
Hello.
Hello, and I'd like to say, I'm just going to point out, by the way, it's currently about 26 degrees in England. What temperature's there for you right now?
-2.
I mean, trust me, I've got clouds, so it's, you've got clear skies at least, so we're always grateful for that. I think it's, generally speaking, a given that Paul has some kind of anti-cloud device, because he's managed to bring us clear skies more times than I can actually count now, so I think he's secretly working for some alien organization that can clear clouds for him. And if so, I'd like in on that action, please, because I bought astronomy gear recently, and I've got clouds and rain and everything else that comes with buying astronomy gear. So, Dylan, you can probably thank me for that Arctic front in Australia right now.
That's right. It's all your fault.
I do apologise. So, you are watching the Global Star Party, where we aim to bring live views of things in space, whether that be planets, moons, galaxies, twitching black things, which I'm going to skip over to in a second because I'm really curious as to what that is. But you can follow us on Twitter at Global Star Party. Tweet us out, hashtag GSP, and I'll pick up on that if you have any questions or feedback. I am watching the event page, so you can ask questions, comments, things like that, and ask Paul to bring us, stuff in space. Just come up with some really tricky things for him to try and find, small satellites, asteroids, etc. And we'll give it a go. And you can also talk to us in the Q&A app, which is somewhere in the bottom. If you're watching on YouTube on the event page, I'm going to move my fingers down a bit there. There we go. Somewhere along here, you can click on that and you can ask us questions, say hello, tell us to lick our elbows if you're a troll, things like that. So welcome. And I'm going to click on Paul, and I'm going to go, Paul, what we got?
This is Pluto.
Oh,
These two images were taken about 2 hours apart, just before the GSP started.
Nice. Awesome.
Of course. Pluto is the planet of the year right now, or dwarf planet of the year, I should say, with New Horizons flyby happening just in a few days. So we are wall-to-wall Pluto news at the moment. Every single day we're getting fascinating new images showing the new geology and new features that we never knew existed before a few days ago.
Including that love heart.
Yeah, and the love heart feature. I love Pluto. This blinking that you see on the screen here is a common technique that's used for finding asteroids and finding comets and anything in space that might have an orbit closer to our solar system. than the objects far off in deep space. And when Pluto was discovered in the 1930s, it was this exact same process that we're seeing here on the screen, except back then it involved standing or sitting in front of this metal contraption that flicked big plates up and down really quickly, and you didn't have the luxury of having the image inverted like this, so you could see it nice and clearly. Yeah, Pluto was discovered just like this, by blinking an image and watching it move.
I mean, this movement you're seeing here it will be partly Pluto's movement, but it'll be mostly the movement created by the geometry of our rotation versus the star field in the background as well, because Pluto's orbit is a ridiculously long orbit. I think it's 240 years or something like that to go around the sun once. So, in fact, New Horizons is there speeding away towards Pluto, and there was an interesting point made that they weren't actually sure exactly where Pluto was, because we haven't seen enough of its orbit yet to really kind of nail down its exact position in space. So it's one of those things that they're going to keep making adjustments as they head towards it. But I can't believe we've got Pluto. Pluto, relatively speaking, live too, and also technically, I suppose, Paul, you've captured New Horizons in there. There will be
Right.
there will be a photon possibly made it to your telescope from New Horizons. That is pretty awesome, Paul. Once again, sharing and saving the day with his incredible clear skies. So, Paul, I will let you line up the next target, and I am going to go and share out a recent image I did. So bear with me a moment whilst Paul lines up what looks like a globular or globular cluster. Votes in the Q&A app, please. Right then, so hopefully in a second you guys should be able to see that.
Oh, very nice.
It's the Dumbbell Nebula M27, also sometimes known as the Apple Core Nebula, because if you don't quite expose that faint blue kind of edging there, it looks like a bit of like an apple core.
And tell us a little bit about how you process this image.
This is, as anyone that's been watching the show will know, I recently bought a CCD camera, but I had no filters for it. And because of that, I was able to take only luminance information. So I took 10 photos of this object. Each one was only 60 seconds in exposure, but binned 2 by 2, so kind of doubled up the sensitivity. And then I used old color data from an SLR photo I took a few years back, and used the black and white image from the CCD as a luminance channel to kind of add in the stars and bring out the detail, and using the color from the SLR just to give it that pretty color that you see there. But huzzah, and this is why everyone's got bad weather now, I now actually have some narrowband filters. So as soon as the clouds break and desist, I will be trying to photograph this object again, but in hydrogen alpha, oxygen 3 and sulfur 2 wavelengths, creating a kind of tricolor image, but not your typical RGB kind of image, and hopefully expose more detail, because there's actually a lot more to this nebula that can be seen with an SLR. That is actually...
I think it's interesting that you've taken old data that you've taken on a completely different kind of setup with your DSLR and merged that with the new data from your CCD for the luminance or the mono channel to bring out more detail. And it's probably worth noting that, especially for the lay viewer, we don't take these images just like by putting the camera on the lens and just going click. It takes a lot of exposure time and a lot of, in this case, different narrowband filters or RGB filters or mono or luminance, and you can mix and match. So there have been instances where, an example is where Paul from New Zealand took an image of the moon, and I also took an image of the moon using my own equipment, got them fairly close, and we could do a 3D composite. Astronomers can also collaborate like this from different locations to collect their data separately. So someone can do the HA, hydrogen alpha, someone can do the oxygen, and that way you get a lot more time, a lot more exposure time using different sets of equipment.
I was going to say, I mean, I think this is going to be one of those things where we're going to turn around to Paul and go, right then, Paul, you grab the HA, I'll grab the oxygen 3, someone else grab the sulfur 2, and we'll do a live blend and see how horribly wrong and challenging that is.
That would be a challenge, but I'm up for it.
Just a little bit of a challenge. But yes, I now have inside my filter wheel. I'm going to be a bit naughty and rotate them back. But yes, you can just see there, that is my hydrogen alpha filter, which I can, there we go. And that will be used to take some photos, hopefully soon. I don't want to jinx it though, because this is astronomy, and clouds are the biggest problem in astronomy, as anyone will ever tell you. Now I am going to click back on Paul, who has got something. What have we got here, Paul?
This is the globular cluster 47 Tucanae.
Ooh,
Oh,
I've
nice.
never heard of this one. Whereabouts is it, apart from in the southern sky?
Happens to be in the constellation of Tucanae.
Oh, you see, I'm not familiar with that one. That's cool. Tucanae, is that like a toucan kind of thing? It sounds toucan-y. I'm not
It
familiar
is
with this one.
16,700 light years away from Earth and 120 light years across. It can be seen with the naked eye and its visual apparent magnitude of 4.9.
And it's also very pretty. I'd like to say from a purely scientific point of view, it's very pretty. What was the exposure time on this one, Paul, and what were you imaging with? Any filters or anything?
This is a RGB image of 30 seconds each, binned 2x2.
Nice. And it's a lovely. I like the fact that it seems to be little rows of stars just coming out of it, what have you. I find globular clusters really quite interesting to look at. I've always wanted to stand on a planet somewhere in there and looking up at the night sky. It would be pretty tremendous, I'd imagine.
I don't think there would be a night sky. It would just be daytime all the time.
So you have to wonder actually how dense and how close the stars are in the center there. I mean, globular clusters are, are they held together by anything specific? I mean, do we think there's a black hole in the center of this, or is this just...
Some do and some don't, and this one doesn't apparently. There's no evidence yet, at least mathematically, for a black hole, but it is the second brightest in the sky after Omega Centauri, which we've brought on the show before. So it is a big one.
So that is pretty impressive. I look forward to. It'd be actually quite interesting if something like the Kepler telescope, etc., could look at this for planetary bodies within these. I mean, just being on a planet in that would be pretty epic. I mean,
Yeah.
I was going to say I've observed things like M13 or what have you from my side of the planet, and whilst they're not as spectacular, they're pretty epic. I'm getting a beeping noise in my headphones. So, Dylan, I'm going to go over to you, and you can go all Flickr on us with our Flickr group.
Yeah, definitely. There is one that I wanted to share out. I'm getting that incoming call as well. It looks like someone's trying to join the join the party. This is one that I wanted to share for a while. It was actually something. It's actually in the intro video for the GSP, but I haven't spoken about it before. I'm sorry, Gary. I meant to get to this weeks ago, and I haven't. So please forgive me, but it's here now. This is solargraph. I don't know if you guys have ever seen this before, or a lot of our viewers might not have seen it before. But it's a really lo-fi way to get a massively long exposure, and I'm talking up to 6 months of exposure of the sun, so that you can see the sun's path across the sky change as the season changes, which is really fascinating, I think. And we do get bogged down in astronomy with equipment and the cost of things. The cost of doing something like this is a few bucks. It's a beer can camera. You can make this from old photographic emulsion, just black and white photo paper. You can even use expired photo paper. So if you're just trawling through the wreckage of the local Kodak shop that doesn't exist anymore and you find some old black and white photo paper, grab some, go into a relatively dark space and cut up a beer can, shove some of this inside it, prick a hole in the side and tape the thing to a tree or something stable for 6 months. You don't even need to develop. You just pull the paper out, and you'll see that it's been exposed to these small amounts of light for such a long amount of time that it already has an inverted impression on the paper. And then you just scan it in or take a photo and invert that in whatever program you're using, and you end up with something like this. It's just a tremendous, fascinating image and process, and I really like it. I've already ordered a bunch of photo paper off eBay for $20, and that'll be enough to make 50 cameras at least. It's so cheap.
So
you can see even the trees, because it's such a long exposure. The trees have no leaves on them, but they sort of do. They're sort of a ghost tree.
I was going to say, Bob mentions here that it's a pinhole. So yeah, I mean, it is effectively a pinhole, isn't it? It's just a pinhole camera, long exposure. And I'm assuming the gaps in the sun's trails there we're looking at are, I'm guessing, clouds, weather changes over the seasons.
Yeah, that's right. You see these gaps here are definitely, clouds. So that's probably a good measure of how much sun you get over a particular amount of time.
So, and I mean, one thing you can tell here is obviously the sun being lower to the ground there is the winter months, and as it gets higher and higher, we get into the summer months. I mean, that is pretty awesome. Right. I'm going to say I have to try that out myself at some point. Although most of mine would be just clouds, sun, clouds.
Now I'll flick over to another one. Is it possible for you to just shoot Kevin Franklin an invite link while
yes,
while I'm rambling on?
Just rustling them up.
So the next one here is from Wendy Clark, who submitted this to our Flickr group. Wendy's got some excellent stuff in the Flickr group, actually. So thanks for submitting that, Wendy. And that's another one of Pluto, and she has the blink process as well, just to prove that it really is Pluto in that massively dense exposure there. So good job on that, Wendy Clark. This is one from the infamous Paul Stewart. I just had to bring this into the spotlight because it is from today. Today's sun in calcium K, and those sunspots are just really, they're quite small. So for Paul to bring this out at such beautiful detail and depth is just a testament to his processing and acquiring abilities. Another one from Wendy Clark here is the solar prominences from yesterday. So we really appreciate these very recent views on the global star party. So thanks, Wendy, again for submitting such fresh stuff to the group. There's the Dumble Nebula, which we just discussed. Another from Kevin Franklin, who is trying to join the group as we speak. I'm not sure if we're having trouble getting him in. He's often on the calls with us. How are you going there?
And I'm just going to click on Paul here, who's got something. It's definitely something. It's a lot of stars.
This is just a small part of the small Magellanic Cloud, a companion galaxy of our own.
Oh wow!
Nice.
Fantastic.
So because I am completely unfamiliar with this part of the sky, and I'm just still learning all this stuff. So we are looking at the center bright cluster of stars there, and then there's this bluish kind of cluster to the left, bottom left. So I'm trying to.
Is that really, really low on the horizon there, Paul?
No, it's not too bad.
Nice.
Okay.
And you've got some lovely star color in there again as well. How long was the exposure on this one?
Still the same, 30 seconds each channel.
Nice. And Kevin has managed to join us. Good evening, Kevin.
With a
Sorry,
live
I'm
view.
late, gentlemen. Have you got my audio?
Your audio is good. And
Excellent.
look at that. Look at that live Saturn.
Despite all the weather reports, Dylan might have told you we're looking at the storm of the century here in southeastern part of Australia, but it hasn't quite got to us on the Gold Coast yet. So while we've got some clear skies and not too bad seeing, actually, I'll sit out and maybe do a bit of imaging while I get a chance, because there may not be such opportunities for a little while.
This is true. And nice. I mean, the Cassini division there is nice and clear too. That's normally a good sign of decent seeing.
You know, like you're about to start doing, I go through filters, and this is through a luminance filter, so it's a monochrome image. And when I'm doing the imaging, I'll do a red, green, and blue series and use the luminance for my detail. So this is the sort of detail I'd be looking at. This is with a 3 times Barlow lens.
Nice. So what kind of focal length are we talking about here?
Oh, hang on, I can tell you that right now because it tells me that it's 5,300 millimeters.
Ooh.
So that's yeah, quite close up and personal.
Yeah, that's basically the same as having a 5 meter long tube, and yeah, that's quite a focal length. That's brilliant.
How long does it take you with the filters?
Oh, it takes a little while. It probably takes about eight minutes to do a full imaging run. So three minutes for the luminance and 1 minute each for the others, and the rest of the time is spent refocusing and changing filters.
And do you have to do, I don't know what the deal is with Saturn, but do you have to do any derotation after 8 minutes with that sort of data? Or?
No, not with Saturn. It's got a slightly longer rotation time, and the detail isn't as important, let's say. There's bands, but you haven't got the spots and the clouds and the stripes like you do in Jupiter. With Jupiter, it's absolutely critical to derotate. With Saturn, it isn't such a big deal.
I mean, Jupiter's rotation rate is pretty fast.
It's about 10. Jupiter's is Jupiter's 9 hours. Saturn's 10 hours, but it is smaller and further away, so it isn't as critical. And just the detail isn't there in the clouds for much of the time, so you really don't need to worry too much about it. And anyone who's ever used WinJupos for derotation knows that it can be a very fiddly process.
I have not yet tried that, so
Oh no, it's all sorts of fun.
Yay! Looking forward to learning that one. I'm going to just start with narrowband imaging stuff that doesn't particularly move. Unless you're the crab nebula, but I think I've got plenty of time to try and photograph that one.
Do a time lapse.
Yeah, that would be pretty epic. By the time I'm, 80 years old, I should have some decent motion. Fantastic. 50 years or so to go. Oh, that's slightly sad. And we've also been joined by Grant as well.
Hey, Grant.
Good evening, guys. I can't part of the thing at the observatory today. I have a meeting. I hope you can hear me okay because I'm on my smartphone. I thought it was just a good idea just to participate and show willing here. The last show was fantastic. We had a great time.
Glad to hear it. Glad you were able to join us.
Yeah, thanks.
Sweet. Well, look at this. We've got live Saturn, live Deep Sky, and Russell, I'm assuming, is being currently skunked on by clouds, I'm guessing. He was possibly able to bring us live sun from the wonderful cold of Canada, but you know, it's the clouds are always a pain. And Kevin's gone all kind of zoomed out on Saturn now. Are you going to bring us some moons of Saturn? I think he is. The exposure is going up. And then it went dark.
Maybe that storm arrived. The storm of the century just arrived.
Yeah, no. I was going to say, I don't actually know where Saturn's moons are currently. I don't have Stellarium up, but yeah, what Kevin's doing here currently, he's set the exposure much higher because compared to Saturn, its moons are much dimmer. So you overexpose Saturn, and in theory, you can find moons. Titan being the easiest one because it's Saturn's biggest, I believe. Yes, and it also has a cool atmosphere and kind of looks orange through a telescope, assuming you don't have clouds in the way. It's always the challenge. What's Paul got going on here? Has Paul got anything new? Oh, that's a lot of stars, Paul.
The thing we're looking at is a place without any stars. This is a dark nebula, the constellation of Ophiuchus.
Now, Ophiuchus is my star sign, but we'll skip that subject. Like it. So, apparently Kevin's lost my audio. Is everyone else able to hear me? I'm assuming everyone can hear me. Hello, world.
I can hear you. Yeah, I can hear you fine. I can hear everyone. And Paul, I just wanted to ask, with this image. Is this the one up near the Scorpio region?
It is getting close. They call it the Pipe Stem Nebula.
That's not
And
quite as
dark
close as
nebula are
spaghetti
just clouds that aren't being energized by kind of solar activity near them, so they blot out. We can't see through them.
or inside them. I'd be kind of curious to see if there's anything in there. You know, rogue planets, black holes, alien fleets, things like that. You know. But dark nebula is something that I've never really looked at, so to speak, before. So
Well, now that you've got a CCD,
yeah, I'm going to give it a go. I'm going to see if I can find those nice dark clouds. So, I mean, how much? Paul, this looks like a pretty wide field of view. Are you using anything like Dylan's Hyperstar here, or is this? I mean, what kind of setup are we using to get this?
This is just a 132mm f5 refractor.
Nice. I was going to say, now I'm looking at this. I'm like, there seems to be like a darkish area off to the right-hand side, the central dark area. It's pretty cool to see a nice dark area. Now
hey,
then,
Paul, I don't know if it's in your sky, but can I make a request? Can you see the Flying Spaghetti Monster Nebula?
Give me some coordinates. I'll see if I can find it.
It should be otherwise known as the War and Peace Nebula, or the Lobster Nebula.
Yep, got it. Give me a few minutes and we'll get there.
nice.
Awesome.
So yes, folks, if you're in the Q&A app, you can send out requests to Paul. I mean, you know, have a chat with us. Now then, I've got a question here actually. Hi, do light pollution filters really work? It depends on what you're imaging, and I'm going to generally say yes. You can have ultra high contrast filters, and they will allow you to observe nebulas, things like that. They don't particularly work with galaxies because of the nature of the light coming from galaxies, but they can be used for nebulas and things like that. When it comes to imaging, narrowband almost completely eliminates light pollution. But yes, light pollution filters will work, observing-wise anyhow. I've never used an ultra-high contrast filter with imaging. Does anyone have an experience of that in the panel?
Yeah, I've used one. It's one of those things. You put a little bit more glass in the way, and you've got to expose for a little bit longer. They do work, but they're not going to work if you're just sort of hanging out under the street light. You're still going to get casts on your image. You're not going to get a completely flat field from edge to edge. So light pollution filters are good, and they'll definitely help improve the overall quality of the image, but I wouldn't use them as a panacea for just obliterating light pollution in general. For that, I would say definitely experiment with narrowband. I've been doing a bit of narrowband with my hydrogen alpha. I'm new to this with Chris as well, and it's so much fun. The moon is not an issue anymore. The street lights aren't an issue anymore. You can, as we saw with the last episode, the last couple of episodes with Asteroid, you can be in the middle of Sydney and be doing unbelievable stuff. So narrowband's definitely the way to go. And you know, light pollution filters come in all kinds of different types and varieties and bands and quality factors. So I couldn't tell you if any one particular one was better than another, but it is nice to, if you've got the luxury of having a little bit more exposure time, then pop a light pollution filter in there for sure.
I was going to say, light pollution is the bane of anyone that lives in, well, anywhere really these days, thanks to sodium street lamps and things like that, city lights and what have you. Now, Grant, I mean, do you use any filters at all, or I mean, do you use any filters for observing or imaging?
Yes, I've very, very fortunate where my observatory is. Light pollution is virtually non-existent. I've normally found that, as well as what Dylan said there, that if I fit a Ratten-coded 80 alpha blue filter onto cameras, that does cut out a certain percentage of light pollution. On my SBIG, I've got all the filters: LRGB, hydrogen alpha, oxygen 3, and sulfur 2. But as I said, where I am, I'm blessed with dark skies.
I am somewhat envious, but I saw some movement on Paul's screen there. I hope that answers your question, Michelle. Now then,
Actually, Kevin's got those moons up.
Has he got moons?
Yeah.
Moons of Saturn. Look at that. Now, I'll let Kevin tell me, but I think that the far right-hand one, that's the easy one, is Titan. I'll let Kevin fill in the rest. Or maybe Kevin's really quiet. He's gone shy on us. Technology may be the issue.
It is also harder to wax lyrical about what you're looking at when you're actually doing the acquiring as well. You're standing out in the cold and fiddling with knobs and trying to actually do this stuff. So that's why you've got Chris and I here to fill in the blanks.
I like putting pressure on him though. It's fun, but still. I mean, like that. What can I say? But yes, I mean this is fantastic because the moons are actually a nice configuration with them there. Titan is on the right-hand side. You see, bless him, Kevin is giving to go via messaging. Titan, right-hand side, definitely Titan. I'm going to say Dion? I'm terrible at pronouncing these astronomical objects. It's terrible. I am shocking. I really should get better at this. You think with a British accent and everything, I'd be, really good at pronouncing stuff. But I am going to cheat. So bear with me a second. Right then.
Oh, here he goes. He says, from above left, Tethys, Diona, and Rhea.
Ah, Rhea. Nice. And of course, Saturn has many more moons than this. Saturn has a lot more moons than this, but they are the largest ones. And Enceladus is right close in. Ah, yes, I can just see that. Enceladus is a fascinating moon as well. Possibly has life in its oceans. We don't know, but it'd be nice to land a probe there and find out. Enceladus is the one with all the tiger stripes on it, if I remember rightly. It's got a red, veiny bands that might be signs of some kind of process deep below the ice. I get slightly excited there when it comes to this kind of stuff because I always imagine that they're going to land a probe and there's going to be moon aliens and giant whale things or squids. Talking of squids, I wonder how Paul's going with the acquisition of squid monster thing. Spaghetti monster, sorry, it's spaghetti monster. Most of these objects in the night sky, apart from your classical objects, kind of arbitrarily named as to what they roughly look like. And astronomers are not particularly good at naming things, but some of them are pretty inventive.
Yeah, I mean, I can understand the Eagle Nebula. It's so majestic and wonderful, and then they go and name something just up the street, the Running Chicken Nebula. It's just common usage. There is no committee of people who voted the demotion of Pluto. They're not sitting around saying, well, is the running chicken going to be in or out? That's up to people like us who actually image and talk about it. It's up to usage, just like any common language. If we start calling the Lobster Nebula the Flying Spaghetti Monster Nebula, then so be it. It's the Flying Spaghetti Monster Nebula.
And it may just stick as well. I like that. Now, is this the Flying Spaghetti Monster that you're on about?
It sure
I
is.
believe so.
Look at his noodly goodness.
That is fantastic. Now, what constellation is this in?
It is.
Like, because there a spanner in the works?
Scorpius.
Scorpius. Ooh, I could image that.
Yeah.
Maybe. I don't know. So we've got 4 very bright stars. That's probably quite easy to find visually speaking then. And it's very dense towards the right-hand bottom there. Dylan, you've imaged this one recently. Do you know much about this nebula?
Yeah, I know a little bit about it. It's, I mean, they call it War and Peace because it looks like a skull and a dove when it's in infrared. It obviously looks completely different in RGB. It's got these massive 4 stars which you see across the middle there. And for a long time they were thought to be some of the biggest stars just in terms of solar mass on record. But I think since then, through further surveys and what we know now, that they're not the biggest, but they are certainly massive. massive solar masses in there. Let me just find, I did mention that I've been having fun with hydrogen alpha, so I'll just throw up my hydrogen alpha of this. It'll be a sec. Okay, can you see that one?
Yes, yes, we can. Now that is...
Yeah, this is the same target, but with obviously a lot more time. Paul has just had a few minutes to quickly skip over and image this in RGB, which is unbelievable to do so quickly. This one, in comparison, is a whole hour and 20 minutes worth of acquisition. So I've spent a long time doing 20-minute subs in hydrogen alpha. But now for the astro nerds, this is actually done on a one-shot color camera, which is not the thing to do, because you've got RGB pixels and the hydrogen's only hitting the red pixels. So in a sense, I'm losing 2/3 of the resolution just by doing this. It was a bit of an experiment, and what I like about it is that it means that I can image while the full moon is out and still get all of this extra luminance data that I can then throw on top of the RGB data, just as Chris was showing us before with the Dumbbell Nebula as well. So there you go, that's the Flying Spaghetti Monster Nebula. Remember that one.
I like that name. I'm hoping it sticks. Now, Russell has live sunspots. Look at that. Nice one, Russell. Technical issues aside, you've got focus and sunspots.
Thank you. You finally got it all working.
Nice. Now, do we know the names of these active regions, or are they sorry?
I think it's 2381.
This is 2381.
Nice.
Yep.
That's fantastic. And what are you imaging this through, Russell?
5-inch Smith-Cassegrain telescope and a Mylar filter.
Nice. So the Mylar filter is something that sits in front of the scope. It's kind of a film thing, I'm guessing?
Yes, yeah. A batter filter, like a...
Fantastic. I like that. Now, sunspots are always fascinating to me because you know, they're the source of great activity on the sun, and they're always kind of fun to watch them go around. But that's
Hey, can I ask, Russell, can you give us a little bit more detail about the tips and tricks for this acquisition? Because I noticed today I was out imaging this same sunspot with my 4-inch, which is not too much different from yours, and using the film, which again is exactly the same as what you're doing. And I'm not getting anywhere near the detail that you're getting, and I see some of the stacks that you're doing in it. They're just unbelievable. Can you give us a bit of insight into your process?
I pretty much just go with what I see on the screen. Focus is really key with the sun. If you're out of focus at all, it really doesn't look right.
Mm-hmm.
Say focus, seeing, and clouds. You need a lack of clouds, good focus, and good seeing, and you're pretty much good to go, I think, for a lot of things. But I mean, that is now what kind of focal length are you using to view this?
This is f7, 625.
Nice.
Mm-hmm.
Nice. So it says. You see, the sun is a massive object. Of course, it's roughly the same size as the moon in the sky, so you don't need ridiculous focal lengths to get some nice detail out of it. And so also, the less focal length you're using, generally speaking, seeing is a little bit more forgiving on you.
That's probably why it is really morning, because of the shorter focal length. I think at f10 it wouldn't look quite as good.
I was going to say, I want to get a solar filter, a white light one for my f10, but I suspect focal length I will need a reducer on there, because I think, again, it's going to cause problems with seeing conditions. But sunspots are always great to watch going around. Of course, I mean, the sunspots have been observed since very early days within astronomy using projection and you know, good old-fashioned bits of paper, because, of course, looking at the sun is very dangerous. I also noticed in the right then, here's a good question. We got one here from Bob Izam. Do flares and things only come out from sunspots, or do they come from other places as well?
I don't know a hell of a lot about the sun, but I know there's a whole lot of stuff happening in all kinds of different spheres, the magnetosphere. So there are coronal holes that we can't see in this wavelength. So I would guess, and this is a guess, and someone please correct me if I'm wrong, that yes, you do see flares from and well, at least solar wind and other kind of ejections, not just from sunspots.
Yeah,
let me know if I'm wrong on that.
I was going to say, I mean, I'm not an expert. I mean, I'm still learning when it comes to the sun, but I believe that, I mean, I've seen filaments and prominences nowhere near sunspots before, but I've only ever seen flares come out of sunspots. I've never seen them arbitrarily about. I mean, Paul is a fantastic solar imager. He might be able to say otherwise, but to the best of my knowledge, sunspots are the source primarily of flares, and just nice kind of active changes in the surface detail in terms of granulation and penumbra and things like that.
Hey, can we flick over to Paul, because he's got one of my favourite objects.
Okay, I have no idea what we're looking at, but okay, I have no idea.
Paul, tell us what we got.
This is M8, the Lagoon Nebula.
Nice.
Yep. Lagoon. It's another one of these really big, bright ones. So it's you can tell even just with a quick acquisition here, it's massive. And we get I only usually expose this for 2 minutes, and it almost overexposes. It's that bright.
Now then, I am actually I have some vague knowledge of where the Lagoon Nebula is. Does that mean you're quite close to the Trifid Nebula then, Paul?
Yes, I would be.
Is that below or above your horizon currently? I don't know my orientation's completely off.
It's fairly high in the sky at the minute, I think.
Well, I'm going to be, I mean, as much as the Lagoon Nebula is very pretty, I am going to say, hey, Paul, do you want to try for the Trifid? Because
Paul is just acing it as usual.
He is the master of this kind of imaging. Although, I mean, the competition will be on if I get a clear sky and I can go all narrowband for a show. But of course, that will be possibly next week's show. I don't want to jinx it, but next week's show is when the Brit that's doing all the talking right now kind of feels really sleepy and has just done a pub shift. But I will try to bring some live skies. I'm a bit more compos mentis when it's daytime and cloudy here. Also, we have had a question. Oh, no pressure, Paul. Now, right? We had a question here from Devin going, "Any comets in view for Paul?" So, Paul's there going, "Why me?"
Oh God, that's a big ask. I mean, I'm sure given some time, Paul could definitely do a comet, but there are no big bright ones at the minute. They're all slow and low.
I was going to say, I've loaded up Stellarium now, so I can just arbitrarily click on things, go, Paul, that looks like it's close to where you could look. It's the great picking on Paul thing. But one thing that we did actually bring up in the pre-show, when we all started, to try to get past all our technical problems and we're chatting to each other and having cups of coffee and sorting out problems, we were talking about how a friend of mine is looking into getting a telescope, and the way she was talking about it was that she was expecting to look through the eyepiece and see these fantastic colours that you see in Paul's pictures, my own pictures, Dylan's pictures. In fact, everyone that really does astrophotography can bring in some beautiful, colourful images. But it's trying to convey, and I think it's an important thing to know, that if you are doing observational work when it comes to looking at things in space, these objects do not appear bright and colourful because our eyes don't have, first of all, the sensitivity, and they don't do long exposure, unfortunately. So you can't hold the shutter in your eye open for 10, 20 minutes at a time to let all that light pour in. There are some nebulas out there which are very colourful, even to just casual observation, such as the Orion Nebula I can think of, and even the Dumbo Nebula M27 from personal experience. But for the most part, they will appear as kind of grayscale, cloudy things through the eyepiece, unless you have a light bucket the size of Hubble, and then I think a lot of things will be very, very colourful. But unfortunately, your eyes just aren't sensitive to the very, very weak amount of colour light that's coming in. So you're using kind of the kind of the black and white sensitive side of your eyesight. He says, doing the weird hand gestures there. But
it's true, especially when you get into astronomy societies and astro camps and stuff like that. There tend to be two groups, and there's the visual group, the visual observers, and there's the imaging group. And it's fair to say that most of us are in the imaging camp because it's just what we do. But I must say, as soon as I got a telescope for the first time and did some looking around and exploring and went, yeah, that's pretty cool, but I have to put a camera on this and I have to do long exposures and try and reveal some of these structures and this detail that you can see in the Lagoon Nebula and these beautiful colours that are there that we just can't see. So they are there, and there is something revealing and really nice about seeing the images pop up on the screen and then being able to stack them later and draw out that detail. So much so that whenever I'm out in the backyard imaging, and I ask Anna if she wants to come and have a look, and she says, no, just show me the photos later.
I mean, I was going to say it's one of those things that I originally got into astronomy because I wanted to see the planets and I wanted to see mountain ranges and what have you on the moon. But it's one of those things that you'll either stay quite observational and you'll enjoy looking at things and trying to find them. Trying to find these things manually as well is always quite a fun. I use the word fun loosely in the cold British winter, but it's quite a fun thing to do. I mean, Russell is a legend for surviving cold weather. I mean, this is a man who drags a telescope out and it's X number of feet deep in snow. So. There is a certain addictive quality to this, but you find as soon as you stick a camera in, it opens up a whole new and I pardon, sorry about the pun here, but it does open up a whole new universe to you. And you saw that one coming from a mile off. I'm sorry about the pun there, but imaging. I mean, this is one of those things that, I mean, if you are watching this show and you have a camera much like a CCD, an SLR, I mean, there are so many different types of cameras that you can plug into a telescope. If you have that ability, then please feel free to drop us a message, join the, follow the page, drop us a message, tweet to us, and we'll see if we can get you and your view of whatever we're looking at into the show. I mean, this is I mean,
we're always
have
looking for new astronomers.
I mean, we have our regular panel, but even Paul can't necessarily, do no clouds every time. Even though I reckon he does have that secret device that gets rid of clouds. There's some kind of cloud filter technology or some kind of massive laser cannon that points away, that burns the clouds out. But please do join us. We have our Flickr group as well, which you can find Global Star Party on Flickr. If Dylan, actually, you could pull up the group page there, and I'll share a view of that out. Feel free to submit images to that. We'll bring them onto the show and discuss what we're looking at. And also, as I say, this is very much we want to bring as much space as we can to the population at large. And there we go. You see images recently submitted, which Dylan shared out a few earlier. We had a bit of a close-up look, including my...
I should note, it is really nice how fresh a lot of these images are. So these images of the sun that you're seeing were taken today. And that one was yesterday. So these are really fresh. So if you're looking for something that's not quite live, but really pretty recent, our viewers really have it nailed.
I was going to say, there's a great community out there. Google Plus for me has been both educational and great to meet like-minded people as well. We joke actually normally off air that we all need to meet up in a pub at some point, and maybe with some telescopes in tow as well. Although beer in telescopes is a bit risky. This can be an expensive hobby if you go down the rabbit hole with filters and what have you. But but please, yes, join us on the Flickr page. Bring in your photos. Give us a little detail about how you took them and what have you, and we will share them out. It is great to look at your guys' work. So there are many ways of taking part in the Global Star Party. And if you don't have a telescope and what have you, and you just like to listen to me and Dylan waffle and Paul run around like a nutter trying to find stuff in space, then it's great that you join and watch with us. And Paul here has got the trick. That. Now, if I remember rightly, the red side of the nebula is an emission nebula because there's really bright, hot stars there filling the space there with radiation and what have you, which is making all those hydrogen atoms bounce around and glow. And then you've got the reflection nebula, which is fainter, but is just light being reflected from nearby stars off whatever particles, etc., are floating around there. That is lovely, Paul. It's an object that's very low in my sky and almost impossible to get, to be fair, because of rooftops, trees, hedges, etc. So that's really lovely to see. So thank you, Paul. That's one of my favourite nebulas, actually.
It is a beautiful one. And I'd also just like to give a shout out to the Astro Imaging channel on tomorrow US time, which is sort of Monday morning Australian time, or Monday midday Australian time. They're doing their weekly show, but the next weekly show is about selecting a telescope, which I think is probably perfect for a lot of our viewers, especially if you're just looking to get into astrophotography or making the jump from visual to astrophotography, or just have never had a telescope before and you're thinking about buying one. This is a kind of really ground level show where you can get into all the different types of telescopes, which can be a bit confusing when you walk into the shop and a guy tries to sell you something and you take it home and $1,000, $2,000, $3,000 later you realise you can't actually take the photos that you wanted to take with that particular rig. So if you're interested in astronomy and astrophotography, definitely check out their episode, the Astro Imaging channel. Look them up on Google Plus or YouTube.
I am also going to be a horrible, horrible, horrible man, and I'm going to say to Paul, oh, look at, sorry, actually, no, I'm just going to...
God.
Look at that. Okay. How have you done this, Paul?
Is this HA?
Not live. So I took last night of the Trifid in hydrogen alpha.
Oh,
beautiful.
I am so looking forward to going hydrogen alpha. I was going to make another annoying request to Paul before we wrap the show up, and I feel almost guilty now for bringing one of my favourite nebulas in hydrogen alpha. But I'm
spectacular.
I'm still going to throw it out there because we still have 7 minutes until the hour is up. So I am going to be a horrible man, Paul, and I apologise. I love your Trifid Nebula, but I don't know if it's visible. Can you get to the Omega Nebula, M17?
Give it a go.
I was going to say it's got a cool name. It's the word Omega. It's to me that's kind of a cool name. It's a magnitude 6 nebula with a surface brightness of 14.15. You can tell I'm in stellarium, can't you? But you know, this is yet another show where Paul has been able to avoid clouds, bring us live. We've had Russell join us with Live Sun and Kevin with Saturn, but you know, we've been quite lucky so far with people being able to do this. But as I say, I'm going to repeat over and over again. This is a show for lots of people to participate in. This is not, you know, a closed group. We want people to join us. So as I say, please do drop us a line, a message, etc., and we will see if we can get you in the show, sort out the technical bugs, and bring in hopefully some views from even more people. Next year, I know this is a way off, but next year is going to be a transit of Mercury in front of the Sun. I'm going to say now, and I'm going to repeat until it happens, anyone with any kind of solar imaging setup that will be able to look at that. I'm hoping to do a kind of a live show where Mercury transits the Sun. That'd be kind of awesome to see. It is a once-in-a-lifetime opportunity as well, because I think the next time it happens is in like 240 years. Unless someone's going to take my brain out and put me into a robot, I'm not going to see that again. So even if I can't bring live views, I'm hoping like a global appeal, global star party. Just, you know, if you can do it and you've got clear skies, let's bring Mercury in front of the Sun. You know, live Mercury and live Sun in the same image would be awesome.
Yeah.
You know, I was going to say, and hopefully as well, with more people being able to bring in views through their telescopes as well, there'll be just a little bit less pressure on Paul, who has melted eye caps for the cause. So the dangers of solar imaging. please do follow us on Twitter as well. We share out pictures that people are bringing in and what have you as well. I am going to be jumping on to the Google Plus page as well and putting in more kind of weekly stuff as well. This is still a fledgling show, but you know, so far I think, you know, we've had live every show, and I don't want to jinx it. So this is an appeal.
Yeah, whenever we go live, just before we go live, I think, oh, is this the one? Is this the show where we have no live views? And I'm surprised every single time. Thanks, Kevin. I know you're not here now because you jumped in before and brought us live Saturn, and this sort of thing happens all the time. We'll be mid-show and we get a live view that jumps in. It's just fantastic.
I was going to say, our beautiful blue marble, as unfortunately due to having to sustain life and an ecosystem, etc., unfortunately has to have clouds. But if we can find the gaps, we will look for them. And
hey, Paul, what do we have?
Well, someone asked for a comet. This is the brightest one I could find.
You're kidding.
Paul.
2013 is US 10.
Wow.
That is amazing. I can't believe how quickly you did that too. That would have taken me, you know, half the night just to set up the, just to try and get the coordinates and punch them in and figure it all out. But that Paramount mount you've got in that observatory, it's just you've got it singing.
Literally bang on center, I'd say. If you could screenshot this right now and measure from edge to edge, I think that is literally bang on center. That is ridiculous, Paul. My mount does not track that well. I find it, and it's normally on the edge of the screen somewhere. That is incredible. How long was the exposure for this one?
That's only 60 seconds.
That's pretty awesome. You can see that lovely kind of hazy glow around it that indicates there's gas and material sublimating off the core there. That's quite fantastic. Does this have a particularly long tail? If you went longer exposure, would this one show up a bigger tail, or is that pretty much the extent of the comet?
I don't think there's much more of it. It's about a mag 8.8 comet.
I was going to say, you must have very dark skies to get that in 60 seconds as well. It's fantastic. So there we go. I can't remember who asked for that because it's disappeared off the Q&A app, but someone did ask for a comet. There you go. Live comet. So thank you, Paul. So he starts off with Pluto, and he wraps up with a comet. I mean, that's not bad going. I'd also like to say
superstar.
Thank you to the now somewhat quiet and suffering technical problems here and there, Russell as well. He brought us live sunspots, which I always love sunspots. I have a soft spot. Thanks to Paul, I have a soft spot to the Sun and the Trifid Nebula. So yeah, thanks Paul for ruining my bank account there. But I suppose, given we are wrapping up towards the hour, I should probably say goodbye from us. Thank you for joining us, looking at live views brought to you from wherever you're sat on this planet, whether it be couch, bed, chair, you know, wherever you are. Even on a bus, you could technically watch live views of space on a bus on your mobile phone. So,
right.
Technology. So, first of all, thank you to
technology. Thank you, Chris, and thanks for hosting the show once again. It's always a pleasure.
It's always good to have a good long natter. We do, to be fair, what the audience don't see is that we do have a bit of a chat beforehand and a catch up, and it's always good to, you know, bully you with regards to your hyperstar setup.
That's right.
I'm just saying. I'd like to thank Russell for joining us this evening, or the morning, or wherever you are. Thank you, dude. Morning there. Thank you for bringing that live sun. I know you know, you've had technical problems, but you know, thank you for persevering. Of course, we can find Russell, I believe, on Google Plus mostly.
Yes, yeah, and on Twitter too. And
on Twitter. So we will put links in. Yeah, we will put links to Russell so you can check out his awesome work. He does brilliant. I'm sorry, I'm bigging you up here, Russell. Don't go too red, even though we can't really technically see you. But you know, Russell brings fantastic pictures of the moon. His high megapixel images of the moon are brilliant, and the sunspots as well. You've got a real knack for it, so it's always worth checking out Russell's sunspots in moon. They are quite brilliant. Sorry to pick you up there, Russell, but you know, I like your work. What can I say? I'm a fan.
Thank you.
And we also have the ever vigilant and somewhat frostbitten Paul. Thank you.
Still -2.
Ah, nice and cozy there. You see, astronomy, it requires dedication and lots of warm blood, and I presume coffee or like multiple layers. When it comes to winter time, I'm normally sat outside wearing 2 hoodies, a couple of beanies, and a jumper or 3 as well, just because, you know, it's horrible. So thank you, Paul, for bringing us fantastic live views again. You've done a brilliant job. And, you know, I need to possibly quiz you about your anti-cloud technology. And, of course, there has been me, your ever slightly rambling, slightly nutty British guy. You can find me on Twitter at @CKMU, also on Instagram as well as @CKMU, and you can find me on Google Plus at plus Chris Kennedy 1 because someone really nicked Chris Kennedy, darn it. And you can find us at Global Star Party and also on Google Plus as Global Star Party. And you can also find Dylan, the legend that is bringing the International Space Station in front of the moon,
on geography.com.
I'm assuming you've still got bandwidth on that website for more people to go and check it out.
Yeah, it did melt down. Made Fox News yesterday, Time Magazine, Yahoo News, European Space Agency Image of the Week. It went absolutely ballistic. There'll be more news from me later on, but it's been a crazy week. So thanks for all your support, everyone. Thanks.
Hey, you know, you bring us TIE fighters in front of the moon and we'll follow you. So that's, you know, always a thing. So thank you for joining the Global Star Party. More next week. Next week's show will be the American Nighttime / British Chris Tired edition. I might actually just, you know, sit back with a cup of coffee and go, hey, Dylan, you can do most of the talking and I'll just snore in the background here. You never know. I might be able to bring first light with hydrogen alpha. You never know. In that case, I'll be fiddling around with telescope lots with this little thing here. So I can't wait. So fingers crossed. As I say, feel free to join us next week. Hopefully more live views. Hey, you never know. Paul can probably bring live sun, or maybe for the first time live clouds. You never know. This man's technology is, you know. Thank you to Bob and Michael for joining us as well. They just put a message out on the Q&A app there, which again, folks, you can join us on the Q&A app for these things. It's a whole interactive thing, although I'm terrible at watching the event page as well, so I'm going to, I think, delegate that one off to Dylan next week so we can keep an eye on the event page. But I am going to go and get a cup of coffee and rest my voice because I have a nice bar shift this evening where I'm going to talk to lovely customers. So thank you for joining us, and goodbye from the GSP.
Bye-bye.